Hello and welcome to the short video by DNVGL Software on how to create and then locally refine a finite element mesh in GeniE. Today we will use this simple model of a tubular joint as an example. Our goal is to first create a finite element mesh and then refine it locally around the braces to make sure that we have a satisfactory mesh quality for a structural and possibly fatigue analysis of this joint. There are two mesh densities already defined in this project. A fine one with an element size of 1 inch and a coarser one with an element size of 2 inches. Initially, we only apply the coarse density to the entire model by selecting everything, then right-clicking on the desired mesh property and choosing Apply Mesh Properties to Selection. We can then open the activity monitor and run the mesh activity to create our first finite element mesh. And this should only take a few seconds here with the coarse mesh density that we have applied. Switching to the Mesh All view allows us to take a look at the results. And that's actually not too bad for a first shot, but as we zoom in a little bit, we can see that the cell size around the braces is a bit too large and that the structure could be more regular in some areas. Now, as a first measure to improve this, let's try to split the model into different sets so that we can assign a finer mesh density to our area of interest. Back in the default view, we can make use of a feature called Plate Shell Edges Offsets on the surface. This feature allows us to conveniently create surface curves around the braces with a given offset. Let's say, for example, 8 inches. After cleaning up and combining these curves, which is not demonstrated in this video, we can use them to split the underlying surface. Finally, we can define a set including all those parts of our model that need a finer mesh density and give it a name. For example, local detail. Now we can assign the fine mesh to the selected set, again via right-click and choosing Apply Mesh Property to Selection. To double-check, we can color code the mesh and make sure that we have assigned coarse and fine properties to the correct parts of the model. Let's run the mesh activity again to see how these changes affect the mesh quality. The result is a much better mesh, as the element size is more reasonable and also the mesh lines follow the outline of the braces more accurately. In GeniE 7.0 or higher, there is another way to achieve exactly the mesh quality you need. With the new Edit Mesh functionality, we have now full control over the mesh all the way down to individual elements and nodes. Let's say we want to refine the mesh around the braces even more than we already did, except this time we will modify the existing mesh directly. All the according tools can be found here in the Edit Mesh toolbar. The feature that we want to use now is the Refine Grid tool. Different refinement factors and methods can be chosen. Let me demonstrate a refinement of factor 2. All we have to do is click and drag the mouse over the region of the mesh that we would like to refine. Very simple and quick. And this can even be applied to multiple concepts at once. But a requirement is that the underlying mesh has to be of regular structure in the form of m times n quad elements. However, some elements in the area that we would like to refine do not show this regular structure. Here, for example, we have a triangular cell in the first row of elements next to the connection between the brace and the vertical chord member. And this is when the other Edit Mesh tools come into play. For instance, the Manipulate Triangle feature lets you grab the triangle and simply move it out of the area of interest. Now only quad elements are left, and we can easily apply the refinement feature to that region on both concepts at once. Here's another example on the other side of the brace. We have two triangular elements where we would like to have quads, and this is what we can do. We can divide this diamond-shaped element into two triangles, then combine these two. Next, we can make use of the split edge tool that will insert an additional node on the selected edge. Now, no triangles are left in our area of interest, and we can apply the refinement conveniently to the brace and the vertical member. In this way, we can refine the mesh locally without modifying the concept model at all. In the end, this is what the model looks like when we have completed the refinement around the braces using the Edit Mesh tools. You've now seen two very different approaches to achieve a locally refined mesh. The first one was to add more details to the concept model by dividing some plates, creating sets, and assigning different mesh properties to the individual sets, to then let GeniE's automatic meshing algorithms create the mesh according to your settings. The second approach was to put less emphasis on the concept modeling, but rather create a coarse initial mesh and then make modifications to the finite elements directly by using GeniE's Edit Mesh functionality. Both methods, of course, will take you to your goal, or even a combination of the two. So play around with it and find out which approach you prefer. And of course, always feel free to share your experience with us and give us feedback. Thank you very much for watching.